Hello everyone, and welcome to Coding with Dom Code Challenge Edition. So for these videos, I always start off by reading the problem description. In a town, there are n people labeled 1 to n. There is a rumor that one of these people is secretly the town judge. If the town judge exists, then number 1, the town judge trusts nobody. Number 2, everybody except for the town judge trusts the town judge. Number 3, there is exactly one person that satisfies properties 1 and 2. You are given trust, an array of pairs such that trust of I is equal to A, B, representing that the person labeled A trusts the person labeled B. If the town judge exists and can be identified, return the label of the town judge. Otherwise, return -1. Looking at some examples here, we see example 1, the input is n equals 2, trust equals 1, 2, and the output is 2. What exactly is happening here? So we have a town with 2 people, that's n equals 2. The trust, 1, 2, means person 1 trusts person 2. Now in this example, person 2 is trusted and person 2 trusts no one. Therefore, the output is 2. In example 2, we have a town with 3 people, n equals 3. For trust, 1 trusts 3, and 2 trusts 3. So 3 is trusted by everyone in the town, and person 3 trusts no one. Therefore, the output is 3. In example number 3, we have another town that has 3 people in it. Person 1 trusts person 3. Person 2 trusts person 3. Normally, if just these were the case, then person 3 would be the judge. However, person 3 trusts person 1. When that happened, we're violating our first constraint. The town judge trusts nobody. Since person 3 trusts person 1, person 3 cannot be the town judge. And since person 1 and 2 are not even trusted, there actually is no town judge. That's why we output -1 in that case. In example 4, we have a town full of 3 people. Person 1 trusts person 2, and person 2 trusts person 3. So there's no person that everyone trusts. So once again, we do not have a judge. Now in example 5, we have a town with 4 people in it. Person 1 trusts person 3. Person 1 trusts person 4. Person 2 trusts person 3. Person 2 trusts person 4. And person 4 trusts person 3. Now, as you can see, person 3 is trusted by everyone in the town. Therefore, the output is 3. Going over some notes, number 1, 1 is less than or equal to n is less than or equal to 1,000. This means that you should expect a town anywhere between 1 and 1,000 people in it. Number 2, trust.length is less than or equal to 10,000. This means that your trust array will have no more than 10,000 people in it. Number 2, trust.length is less than or equal to 10,000. This means that you're not going to have more than 10,000 items in your trust array. Number 3, trust at I are all different. This means that every item in the trust array are going to be distinct. Number 4, trust at I at 0 is not equal to trust at I at 1. That means that you're not going to have to worry about the case where a person trusts themselves. Lastly, note 5, 1 is less than or equal to trust at I at 0, trust at I at 1 is less than or equal to n. That means for both entries, trust at I at 0 and trust at I at 1, aka the truster and the trusted, each one of those is going to contain a number anywhere from 1 to n. So you're not going to have to worry about a truster or trusted being outside the bounds of your town. For this code challenge, we'll be solving LC 997, find the town judge. Now that we got through the description, let's get started. So we're going to start by declaring the counts array. Our first item in the array is going to be none, and we're going to add that to 0 times n. Now what this means is we're going to have the none item followed by a collection of zeros, each 0 representing a townsperson and how many people trust them. Now let's go ahead and iterate through the trust array. For truster, trusted, in trust, colon. We're going to go ahead and keep track of how many people trust the trusted by adding 1 to their array value inside of counts. So at the index of trusted, we're adding 1 where we start at 0. Now, after we're all done navigating through that array and counting how many people are trusted, now we can figure out who the judge is. We're going to say for I and count in enumerate counts, colon, if count is equal to n minus 1, then we're going to go ahead and return the I. Let's go ahead and try this for this first test case. There we go, success. Let's go see what happened. For our input, we have 2 people in the town, n equals 2. And we also have our array trust has person 1 trusting person 2. And our output is 2. That means 2 is the judge. In this case, that's obviously correct. Let's take a look at our code to see what generated this correct output. On line 3, we have counts equals none plus 0 times n. In this case, n equals 2. So we have none plus 0 times 2. That gives us the following array for counts. None, 0, comma 0. Okay. Now let's take a look at the for loop at line 6. For the truster and the trusted in trust. Well, we only have 1 item, 1 trusting 2. So we go counts at the trusted plus equals 1. So in this case, our trusted is 2. So we go counts at 2. Our counts at 2 is right here. We're going to do plus equals 1. That turns to 1. Now line 9, for I, comma count, and enumerate counts. So now we're going through our counts array. If count equals n minus 1. So the count is equivalent to n minus 1. So basically we're looking for an item where the count is equal to 1. We find it right here. We return I. That way we return 2. That's how we get our output equal to 2. Now let's go ahead and try another test case. Example 2. 3. Let's go run this code. We're still successful. Awesome. Example 2 works very similarly to example 1. Both person 1 and person 2 trust person 3. What that means in our code is that for our counts array, at index 3, it's equal to 2. So the value for index 3 is equivalent to 2. That sets this off, and we return that index. Great. Let's go ahead and take a look at example 3. So n equals 3 is still, and then here's our new trust array. So we're hoping and expecting to get output equals -1. Oh, we get the wrong answer. We're outputting 3, but we're expecting -1. What happened here? What happened is that the potential judge, person 3, is actually not the judge. Person 3 proved that they were not the judge when they trusted person 1. We're violating our first constraint. The town judge trusts nobody. So in this case, we're actually not supposed to have a judge. So instead, we're outputting 3 as if that person was the judge, but really we should be outputting -1 because there really is no judge. How do we fix this issue? Simple. We take our counts and we reset the truster to be -1. That way, if we reset the truster to be -1, they'll never be able to increment up to the amount needed to be trusted. And if we don't return anything for the index, we just return -1 down here. Great, now let's try it. Success. We also get success for example number 4. As well as example number 5. Great. Now let's go ahead and submit our code. Awesome. Thank you for watching and have a great day. And don't forget to like and subscribe. See you next time.